Let's continue with the other part of the CHIME2 pipeline as one of the great bioinformatics processing workflow. Here is the conceptual workflow of the CHIME2 pipeline. As you can see in the sketch here, we have the different steps that are involved in the processing, and normally the data are imported in CHIME2 artifact to be used by CHIME2 action or CHIME2 command or CHIME2 plugins, except for the metadata. So you get the raw sequence read, and as I said earlier, for the high throughput sequence data, normally we pull several samples or several sequences together, and then we have to do demultiplexing. Here you assign, there is a plugin that does the demultiplexing, where to assign sequences to their respective samples based on the barcode that were used during the sequencing. Then you get the demultiplexed sequences. Now here the sequence are defined based on the sample sources, and from here the multiplexed sequence then can be merged. You can join the sequence to get a merged sequence. After merging the sequence, then you do the denoising. Denoising, you remove all those noises that might be present in the sequence dataset. You remove all the poor quality bases or poor quality sequences, or much shorter sequences are removed one. After remove those one, then you create a representative sequences like we have seen in our CBio pipeline or the mother pipeline. You get representative sequences, but again here you get also the feature table. The feature table here is like you have all the sequences that are present in your data set, but you also have the frequencies of those sequences in each type of sample where you have collected them. So from the representative sequence, then you can do the alignment. When you align sequences, there is a tools for alignment, then you get the aligned sequences. Then from the aligned sequences, then you get the phylogenetic tree. Again, from the taxonomy, you do the repetitive sequence, you do the taxonomical classification. There is a tool for taxonomical classification. Then you will get the taxonomy of all the sequences that are present in your data set. Again, from the feature table, now you can do the differential abundance calculation. You can also do the bar plot, heat map to generate different profile of those microbes that are present in your data set. But again, from the phylogenetic tree, you can do further diversity analysis. We see later these types of analysis that are done after generating the phylogenetic tree. But of course, again, you can generate different statistics or plottings from the data. So the most important things the users can, from this, the user can enter the pipeline at any stage in here. For instance, you have done the quality control with the different and the denoising with different types of pipeline. Then you have generated you can enter here with a representative sequence, or you can enter here with a feature table, or maybe you have done the generation of phylogenetic tree. You can do the diversity analysis using the CHIME pipeline. You just have to change your data set in a format that can be recognized by the CHIME tool. Then you can get into the diversity analysis. So at any stage of this workflow, you can get to work with your data set. So you may process your sample with a different package, then you can get into CHIME2 for some specific tests that you are interested in, or those you think maybe CHIME does better than other pipelines, which is quite a good thing. So here are some of the analysis that you can do after getting your feature table and the phylogenetic tree. There are several of them, and of course you can see here, for instance, you have the feature table where you have the frequency of different O2s in different samples. You can do the beta diversities, or you can do the alpha diversity. I hope you guys at this juncture should be knowing what is the alpha and beta diversity. The alpha is within the community and the beta is between the community. So all these statistics can be done using the CHIME2 with different types of plugins. So there is a so-called diversity beta or beta phylogenetic plugins. Also there is diversity alpha plugins, and that can run the analysis. Then you can get a sample data alpha diversities. From there you can do the diversity alpha correlation. For instance, you have your samples. Within the sample you have different types of metadata information, so you can check the correlation between your samples, and you can visualize the result for the diversity like alpha diversities and see these using the tools that are available for CHIME2. But again, you can do the beta diversity. As I've said, you can do the PCOA plot to see how the different microbes present in your sample are clustering. Then you can use the impera plot to visualize those plots. I'll show you later a sample of the impera plot where you can play around to see what's happening when you change the variables that are present in your dataset. So here are some of the selected plugins that I thought should be good for you to see, guys. You can, for instance, if you are working on longitudinal data, there is a CHIME2 longitudinal plugins. Q stands for CHIME, so it's CHIME2 longitudinal plugins. This can perform statistical analysis of longitudinal data. For instance, you have a sample collected from a patient or subject or individual repeatedly over time. This comes up with a longitudinal kind of nature. You have the specific plugin called CHIME2 longitudinal for these types of analysis. And again, if you want to do the prediction of the future or the past, there is CHIME2 sample classifier plugin. This plugin, you can predict a sample metadata as a function of feature data. For instance, if you use the fecal sample to predict cancer susceptibility or predict wine quality based on the microbial composition of grapes before fermentation, all these types of prediction for the future or for the past, there is this CHIME2 sample classifier plugin specifically for that purpose within the CHIME2 pipeline. Also, if you want, for instance, to do the abundance, differential abundance estimation based on analysis of community composition paper, they've come up with this CHIME2 composition plugins. And also there is CHIME2 genase plugins. Both of these are used to determine which feature are significantly more or less in different groups of samples. So based on metadata information, you can play around to see what are the features that are significantly influencing your nature or the nature of the microbes that are present in your data sets. So here is a summary of all variety of analysis of which CHIME2 can do. For instance, from the feature table that you have generated, be it generated using CHIME2 or based from other types of tools, using the CHIME2 you can do different types of analysis just by introducing your sample at the feature table steps. So you can do, for instance, the alpha diversity, as I've said earlier, the beta diversity again, but also you can do, I've said also the longitudinal analysis using these ones. Also you can do to see the pattern, what's happening over a period of time. You can check also what's happened in the past as a function of what you see at the present. You can do a sample classifier, again I've said this one, you can see what are the really representative of the phenomena that you see in your data set. You can do taxonomic analysis profiling. You can see the pattern, what types of microbes were more prominent at what stage of the community lifetime. You can also do the differential abundance. You can see it forms a volcano plot where the features that are significantly influencing, they separate from the rest. As you can see, these small dots here, those are significantly important depending on the variables. You can do a quality control check of your data set. In this case, you might be having a control sample of a specific research. Then you can run your other samples as a function when you are comparing to those control one to see how are they comparing to each other. You can also come up with a dendrogram or a heat map kind of, which shows different pattern of the microbes depending on your data set. Example of the plots that are generated is this microbial profile. This is an output of what you get from the CHIME2 plots, and as you can see here, you can check the taxonomic level at any taxonomy at different levels. For instance, this is level 3, where you have the phylum, we have the kingdom, phylum, and class, but you can vary the taxonomic level here as you wish and get this plot. But here are the samples, so you can change. Instead of sample here, maybe you have different categorization. You can change here maybe as a function of a certain group of samples. You check into here, then you will get the pattern. So it's a very good way of putting out the result which are good for publication, which is only possible if you are using Chain2. Another plot, you can divest the plot, for example, you can have this kind of plot where we see a clear clustering of your microbiome as a function, in this case, for the function of, these are samples from gut, left palm, right palm, and the tongue. You can see these microbes are clustered as a function of this sampled location. As you can see here, for instance, the left palm and the right palm, the microbes from those are clustered together. So these are just few samples, but we can clearly see the pattern. But we see the tongue is a bit away from the rest, though there's one from the left palm. Maybe he swallowed something from there. But also the gut have different microbes. But the good thing about here, you can change the color of these plots as you wish. There's a way you can change the plot. For instance, you can, by clicking somewhere, you get these types of plot, different background. But again, you can also change also the different features. So you can decide what flavor of color you want and what pattern you want. You can do this in Chain2. So here are some of the readings that you can do for the Chain2. Yeah, it's a source, the main source, the website where you find it, and how to install. These are the links to how to download and install this one. There are a variety of tutorials depending on different types of research. This is a very great way of putting it. So I would advise you to go and read this tutorial. You can, in most cases, you'll find what the one that's related to your research interest. But also there is a forum where you can post any query that you think you need a clarification from the author or from other members. So the other pipeline is the Data2 pipeline. This has been generated by H3 Bionet, also at the University of Cape Town, mainly where the PI is. And this pipeline is based on the concept developed by the Benjamin and the other members in the group in 2016. And the Data2 actually stands for the divisive amplicon denoising algorithm. Data2 divisive amplicon denoising algorithm. It's an open source R-based package which corrects amplicon errors directly without construction of the O2. So there is no O2 clustering in here. It resolves to the individual nucleotide when you want to categorize them. So it infers sample sequence exactly and resolves differences of as little as one nucleotide. So when you are comparing sequences, it goes to the level of comparing one nucleotide to another nucleotide of different sequences. The output of the Data2 are the amplicon sequence variants, also named as exact sequence variant as opposed to the O2. So there is no clustering for O2 at 97% as we do in other approaches. And here all the sequences are judged independently. And when they are compared, the comparison is between one sequence and another as a function of the nucleotide, not clustering them. So in view of the potential of this pipeline, the H3 Bionet have developed the two next flow pipeline for the microbiome data processing. You will use this pipeline for the practical session, which I think you will be in a better position to appreciate what's going on with this pipeline. Okay, so in summary, this is the workflow of the pipeline. And again, you must have the multiplexed sequences, then you do the filtering, and then the replication to remove the replication. Yeah, when you do replicate, like you want to get only representative sequences, but you keep the frequencies of each sequence in the O2 table. Again, you do the chimeric identification and the removal, then you merge the paired end reads, then you come up with the amplicon sequence variant or exact sequence variant. And this output can then be imported into our phyloseq package for the downstream analysis. Data2, if you want to install it, you can find it in this link. Yeah. But also there are some good tutorials in this link, so you'll be able to get all this information about the Data2 pipeline, which is also one of the great pipeline available. So in view of that, now I thought maybe if we were to compare 16S and short-genome metagenomics, because some people, they confuse between 16S microbiome study versus the metagenomic microbiome study. So I'll show on this slide